So as we've done before with exponential modeling, we've done linear modeling, right? Line of best fit or parabola of best fit. We can do the same thing with an exponential. Okay, we can use exponential modeling or exponential regression. To model data that appears to lie along an exponential curve and produce a curve of best fit. So in this case, it's not a line, it's a curve of best fit. So you have to look at your points, you have to look at your graph and see if it's giving you an exponential curve or if it's giving you a linear curve or what kind of curve is it giving you. Sometimes the question specifically asks you for things, you have to follow what the question is asking you. Even if you think the other one is more correct, you have to follow the question. If the question says, find me a line of best fit, you're going to have to find a line of best fit. Even if you think a parabola might look better, or even if you think regression or an exponential would look better. You have to read carefully what the question is asking you for. Okay? The question might ask you, find a linear of best fit, a line of best fit, and a parabola of best fit. Then you have to do both.
Can you choose that on yourself?
Yes.
You can choose.
Yeah. I'll show you how. So we have an example here. They gave us the year and population, BC population in millions from 1921 to 2001. Population in millions. The question is asking using a user graphing technology to determine the exponential relation. So here is asking you for an exponential relation, right? So you know in a way that you have to use the exponential, the exponent of best fit. The best fit the data above, where x is the number of years since 1921. What does that mean? Where x is the number of years since 1921. So what would I enter for my x's? Do I enter 1921, 1931, 1941?
No.
What do I enter?
The amount of year gap between 1921 and let's say.
So what would be my year 1921? That's year 0, right? So your x is going to be year 0. How about 1931? 10. 20.
30, 40, 50, 60, 70, 80.
That's right, right? Because x, they want it to be since 1921, the number of years since 1921. So that means your year 0 is 1921. And y is the population of BC in millions. So when I enter in my Excel sheet the numbers, right? What's going to go in the first column is going to be the x value. What's going to go in the second column is going to be the population in millions. Okay? So here's my Excel sheet. Okay? So these are the years since 1921, and this is the population in millions. Okay? So same as before, you're going to highlight the numbers, and you're going to go to, do you guys remember? Insert. And then you are going to go to the scatter plot. Okay? So if you go back here, if you remember this, if you press on this, it's going to give you different scatter plot. Which one do I pick? Which one do I pick? That one.
The first one.
The first one. That's right. So I want something that is scattered, no line, nothing. Okay? Then if I want to add axis, title, what do I do? Remember that? Remember, you go on the plus, and then you're going to pick axis title. Okay? And that would add the axis title right here. So what do I call the y axis? What do I name it? What goes on the line?
BC population.
Population in million. Okay? So population in title for this graph?
BC population in millions.
BC population since 1921.
Yeah. All right. So I have a title. I have axis title. I have a graph. Now I need to find the equation of the curve that best fits. So press on one of the, doesn't matter which point, press on the point, and then right click. If you guys see the add trend line, now you see here that I have different options. The first one is exponential. Second one is linear, logarithm, polynomial, power. Which one do I pick because I want the exponential equation? The exponential. So I'm gonna get an exponential curve, and then to display the equation, I need to press the last two squares. So where one displays the equation, the other one displays the r squared. Remember, the r squared tells me how good is my fit, right? And then anything that's closer to 1, the closer to 1 it is, the better, right? So if you look here, now there's a trick with the equation though, because Excel doesn't give you the proper equation, it gives you an exponential equation, right? So you have to do some changes. So here's what I want you to look. So I'm gonna copy this. Okay. So the equation that Excel gave me is y equal to 0.5252 e to the power of, I can't read this, 0.0268x. Okay? Now, it does not give you the actual base. It gives you e to the power of something. So here's where you need your calculator, and you need to look for the e button. Okay? So find your calculator, and find that e button on your calculator. So you're gonna e to the power of, and then you're gonna put that power, and then you're gonna press equal. Do you see the e on your calculator?
0.0268. Do I have to close the bracket?
Depends on the calculator. Yeah. So yeah, press that, and then put the 0.0268. 1.027. Did we get that? It's 0.0268. Do you find the e?
Yeah, it's right there.
Yeah.
But so like, I think that too, and I just,
No, you have to type in the exponent.
oh,
Just
that's it.
yeah. So my equation, eyes on me for a second. So now, this is my initial population. Okay? It's not going to change. This is the initial population, and I'm going to have to write it as my initial. Then my base, when we did the e to the power of 0.0268 on the calculator, that gave me 1.027 to the power of x. Okay? So what we had to change the e to the power of whatever the exponent is to an actual actual base. So what's my growth factor here? My growth factor is 1.027, right? So the growth factor is 1.027. Always when you do exponential, the Excel sheet, the Excel is going to give you e to the power of something. You have to change it to an actual growth factor. Or a decay factor, depends what you're gonna end up with. Are we okay with this? Do we can find it on the calculator? We know how to do it on the calculator. Okay. Now, the question was asking me to find an exponential equation. I did. Here's my exponential equation. All right, which is y equals 0.5252 bracket 1.027 to the power of x. Estimate the population in 1985.
So, do you do,
Would you switch out the year? Instead of it being 10 years from 1921, it would be, you know what I mean?
So you have to find how many years from 1921 is 1985?
yeah.
Yeah,
Is that what
that's
you
the
mean?
first step.
Okay. And how would that? How would I do that?
You just add on years.
Or you subtract 1985 minus 1921, right? That gives you how many years from 1985 is 1921,
64.
so that's 64 years. Okay? Now what do I do with that?
Put that in the exponent.
Yeah, that's x, right? So then you're going to use your equation. And then you're going to replace x with 64. Because you're looking at the population. So that's about 2.9 million. Right? So if I look at 64 here, so it's about here in the middle, right? And then I go across, that's almost, right? Almost 3 million, no?
2.9 million?
Yeah. Right? If you look here, right? It's almost 3 million, so that makes sense. Yeah? Do you guys understand that?
Yep.
Any questions about it?